The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, today we're going to wrap up Chapter 2, which is going to include Section 8.4. Your homework tonight is to do Section 8.4 and the Chapter 2 review. Tomorrow we will review in class, and on Friday there'll be no class meeting. You will just take your first test. So let's get started. I have some questions that came in via email, or is that via, whichever. And so first of all, this is from Section 2.7, number 34. And the student said that they got the graph correct, but not the interval notation. And we'll take a look at that. But one of the things that I think I mentioned yesterday, I want to point out again, is that when you're graphing on the number line, first of all, you need to be very careful to look at the scale that they're using. For instance, on this graph, each one of these little hash marks is 1 unit. Second of all, graphing in WebAssign on the number line, you don't have to be exact when you've got something like this. You have to estimate it pretty close though, because for instance, if you look at their answer and the answer of WebAssign, they're not quite the same, yet WebAssign accepts this if it's close. However, this part has to be exact. So let's take a look at the inequality. Let's see here. We've got 9/7 times the quantity x plus 1 is greater than or equal to negative x plus 3/7. All right, let's go ahead and clear the fractions. So the least common denominator would be 7, or 7/1. So taking 7/1 times 9/7 would give us 9. So then I've got 9 times the quantity x plus 1, which is 9x plus 9. So the left side of the inequality simplifies down to 9x plus 9. On the right side, I've got negative x times 7, which is negative 7x, and then 3/7 times 7/3, 3/7 times 7/1, which would be plus 3. So clearing the fraction, distributing, combining like terms, etc., whatever, we've got this statement. Going on, I'm going to add 7x to both sides of the inequality. 16x plus 9 greater than or equal to 3. I'll subtract 9 from both sides. 16x greater than or equal to negative 6. I'll divide both sides by 16, x greater than or equal to negative 3/8. Writing that in interval notation, negative 3/8, comma, infinity, bracket on negative 3/8 and parentheses on infinity. So there we have that problem worked out. Okay, now give me a minute here. I'm going to switch some things on the screen. And so let's see, we're going to go to, okay. I know what I was going to do. Student view. Come on. Things are moving slowly here. All right, let's see. They are concerned about 7 number 24. Okay. What I want to do is just look at some of these graphs. Let's see, let's take a look at this one, for instance. Sorry, it takes me a while to switch between things. I'm trying not to show any students' names in terms of work. All right, let's just take a look at this number 12. in WebAssign. This is from 2.7. It says solve the inequality, write the solution set in interval notation. Okay. So this is like 2.7 number 12, -9/19 x greater than or equal to -18. So I'm going to multiply both sides by -19/9. Okay, so on the left side, I get x. I multiplied both sides by a negative number, so I changed the direction of the inequality sign. On the right side, -18/9 is -2/1. -2 times -19 would be a +38. So we get x is less than or equal to 38. In interval notation, it would look like that. And on the graph, let's see here, it would look like that. Now, let's transfer that to WebAssign. So interval notation, I click here and I need parentheses. So where am I going to find? Oh, I've got parentheses on my computer, don't I? So there's a left-hand parentheses. And then I need negative infinity. So let's see, operations, functions, symbols. Here's infinity. So what I could do, I could put a negative sign from the computer and then infinity. Okay. Oops. Now I need a comma and then a space and then 38. Except at 38, I need a bracket instead of parentheses. So let's go back here. Oh, wait, I have brackets on my computer as well. Let's see. Now, there's a problem in that there we go. So that looks like what I've got. So that should be correct as far as the interval notation. Now, graphing, let's see. I need one of these right there. And I need it at 38. So if this is 30, 35, 40, 38, it's going to be right about there. Okay. Now I need an arrow pointing to the left. Let's see what this does. Select, draw, erase, undo. Well, let's see. What if I click on that? What do I get? Oh, a draw. Oh, there we go. There's an arrow going to the left. So let's see if this is correct. And it is. But notice I had to do a little bit of exploring to get familiar with this stuff over here and this stuff down there. And that's part of doing your homework so that when it comes time to take the test, you're ready to go in terms of all that. Okay. All right. Hang on. Let's see here. Let's go back to this screen and trying to remember if there's anything else that I want to do here. Students' questions that came in. Let's see, we got that. Got that. Okay. There's another question, but that has to do with 8.4, and so we'll look at that when we go on later today. All right. So let's go back to the home screen there. Okay. Karina, do you have any questions you'd like to look at?
I don't have any questions necessarily, but my biggest confusion that I'm having is whether I'm supposed to be using a bracket or the parentheses. And I'm confused on which way the direction is sometimes. And I don't know, I'm just really struggling with this assignment.
Okay. First of all, let's talk about the bracket versus the parentheses. Okay. And what I'm going to look at is I'm going to look at inequality statements that have already been solved. So let's say I've got, let's see, -3. Apparently it's not going to let me graph until I click on that. Let's try that now. Here we go. Let's say I've got something that looks like that. Okay. So because it is that, it doesn't include -3. Because it's that, it does include 5. So in interval notation, parentheses means it doesn't include it. Brackets means it does include it. There's a little bit of a clue. It's kind of obscure, but notice this has this line, straight line at the bottom, and so does that.
Yes.
That's just one way to make that connection. Now, graphing this thing looks very much like interval notation. We use parentheses at -3 and a bracket at 5 to show that on this interval, on this graph, we're not including -3, but we are including 5. Okay. Any questions about this one?
No.
Right? Let's look at a different one. I should have left myself more room here, but let's say we have -3 less than or equal to x, negative or x less than or equal to 5. So now they're both going to be brackets. And here they're both going to be brackets because we're including the -3 and we're including the 5. Are you okay with that?
Yes.
All right. How about this one? Oops. So here we're not including the -3 and we're not including the 5. So parentheses, parentheses, line segment in between. So if it's not included, it's parentheses. If it's included, it's a bracket. Okay. Let's look at some more examples. Let's say I've got x is less than 5. What does that mean? X is less than 5. That means that 5, 4, 3, 2, 1, all those numbers in between, way down, just forever to the left.
Mm-hmm.
So forever to the left is -infinity. But -infinity is not really a specific value. It's just a concept of going on forever. So we don't put brackets on a negative or a positive infinity ever. So
Okay.
we've got parentheses there. But let's say we've got this situation. That's going to look like that.
Okay.
Let's graph this thing. We're going to have parentheses, an arrow going to the left, implying it goes to the left forever. And then over here, a bracket with an arrow going to the left. You okay with that?
Yes, and I actually think I just got my confusion where I was at, because I've always had a problem with the bigger and less than, and so I noticed what you're doing, and I'm like, okay, then that's what I understand now.
Sure. Okay. So anything else there?
Nope, that's it.
All right. Well, then let's go on to section 8.4, which is what we're going to look at new for today. Okay. And let's say we have a drawing of, this is 16th Avenue, and this is Nob Hill Boulevard. Okay. YVC is over here and over here and over here, and who knows, maybe someday, but not yet over there. So if this is 16th Avenue and Nob Hill Boulevard, what do you call this piece of street. What is that?
An intersection.
Right, it's the intersection of 16th Avenue and Nob Hill Boulevard. It's the part of the street, or I should say it's the pavement, that is in both streets, and here's the big 50-cent word, simultaneously or at the same time. So this piece of property is part of 16th Avenue, but it's also part of Nob Hill Boulevard. Okay, so it is the intersection of two streets. Now, what if we had somebody that was going to come back, that was going to, contractor was going to repave 16th Avenue and Nob Hill Boulevard, okay? And they were going to pave all of 16th Avenue along with all of Nob Hill Boulevard. So they pave all of this and they pave all of that, okay? That's like the union of 16th Avenue and Nob Hill Boulevard. We take all of Nob Hill Boulevard along with all of 16th Avenue. Let me ask you this though. If a person was going to pave all of 16th along with all of Nob Hill Boulevard, do you think they'd pave this part twice?
No.
No, right. Okay. So the union, you wouldn't list the part that was twice. You wouldn't include it twice. Okay, now let's take this to a different level, different example. Write some numbers down here. Let's say we're going to let A equal the set of numbers that are 0, 1, 2, 3, 4, 5, and 6. Okay, so set A contains those elements or those numbers. Set B contains the following numbers: 4, 6, 8, and 10. Set C equals the set containing the following numbers. And finally, D is the set containing the following numbers as well. The hardest part of this is making this brace symbol. Okay, now some symbols. This means union. Every time I write the word union, I think it's onion, because but anyway, union. Union, the union symbol looks kind of like a U, but without the tail. The union means you take all of everything, okay? All of set A. So if I want, for instance, the union of set A and set B, that would include 0, 1, 2, 3, 4, 5, 6, 8, and 10. Everything that's in A along with everything that's in B. And notice I didn't list the 4 or the 6 twice, even though they're in both. Okay, so in the union, I just list everything in either one of them. All right. Now, an upside down U represents the intersection. So the intersection of A and B is that which they have in common. So that would be 4 and 6. Any questions about that? All right. So again, union is a U, intersection is an upside down U. Let's take a look at some more examples. What about, let's see here, the intersection of C and D? That would be what, -3 and 1 and 2.
2.
Good. What about the intersection of B and C? Oh, they have nothing in common. So there are a couple of ways we can label this. We can use this, or we can use this. This means the empty set. This means the empty set because it's a set with nothing in it. What you don't want to do is this, because if it's an empty set, but it's got something in it, it's not empty, even if what's in it is the symbol for the empty set. I know that gets confusing. So either this or this, the empty set, or also referred to as the null set. Okay. I typically use this symbol because it's easier to write. Again, these things I just find kind of tricky to write. Okay. So that has no solution. So the intersection of B and C, they have nothing in common. All right. Let's look at some more examples that are union. And what I'm going to do here is access my eraser. So I have some more room, because if I go to the next page, I won't have my set list there. Okay. Now, how about, let's see, let's do the union. Oops, shouldn't have put a tail on it. Force of habit. Cud. A cow chews its cud. Okay. The union of C and D would be, let's see, -3, -1, 0, 1, 2, 5, and 8. Everything that's in C along with everything that's in D. All right. Any questions? All right.
No.
As we move forward, that's all right. We're now going to be using the words or as well as and. Or in a certain context that we're going to be looking at means to find the union, and means to find the intersection. The way that I remember this is that if you look at the word and, well, if you look at the word and, in the middle there, it looks like the intersection. Okay. Anyway, that's just little things that I use. All right. Now, the instructions say, solve each compound inequality if possible. Graph the solution set if one exists, and write it using interval notation. Okay, so we've got a lot going on there. First of all, this is what we've got. We've got x is greater than -2, and x is less than or equal to 5. It says solve each compound inequality if possible, graph the solution set if one exists, and write it in interval notation. Okay, the first thing that I would do is to solve each individual inequality. In this case, they're already solved. Next, I'm going to graph each individual piece. It's not required to do the problem, but experience has shown me that it's easier for students to visualize it if we do it this way. So x greater than -2, what would the graph look like? Let's see. We would have parentheses, arrow going to the right. Okay. X less than or equal to 5. We would have a bracket, arrow going to the left. And means intersection. So we want to know, what values do those two graphs have in common? Well, starting at the left end, where do they first have something in common? Right after -2. Where do they end having things in common? At 5, because keep in mind, this goes on forever to the right, this goes on forever to the left. So there's the intersection of those two. So the solution would look like that. Interval notation would look like this, and the graph of the solution would look like that. All right. Any questions about this example? Okay, let's take a look at another one. We've got 5x minus 3 greater than or equal to 2, and 6 greater than or equal to 4x minus 3. So in this case, we need to solve each inequality, and I'm going to recommend that we solve them so that ultimately they have the variable on the left side of the statement. Okay, so the first one, I'm going to add 3 to both sides. 5x greater than or equal to 5, divide by 5x greater than or equal to 1. The second one, let's see here. I'm going to add 3 to both sides. 9 greater than or equal to 4x, divide by 4, 9/4 greater than or equal to x, which means x is less than or equal to 9/4. So I solved the left one, I solved the right one, rewrote it so that x was on the left, brought down the and to remind me what I'm supposed to do. Any questions so far? So now this problem is like the previous one. Okay. So I'm going to graph each piece. X greater than or equal to 1, bracket at 1, arrow going to the right. X less than or equal to 9/4. Let's see, 9/4 is what? 2 1/4, so that's over here somewhere. Less than or equal to, okay. And intersection, where do they intersect? From here to here. So 1 to 9/4. So we've got what x is greater than or equal to 1, less than or equal to 9/4. There's the solution. There's interval notation. And let's look at the graph here, 0, 1, 9/4. Now, let's say this was a web assigned problem and the graph was given something like this. Let's see, -1, 0, 1, 2, 3, 4, etc. Okay, so you'd put a bracket at 1 and then 9/4. 9 divided by 4 is 2 1/4. So let's see, that'd be right about there. And then line segment in the middle. Okay. Any questions about that? All
Nope,
right.
got it.
Excellent. Let's say we've got this situation. 3/5 x plus 1/5 less than 5, and 2x plus 1 greater than 9. So again, we need to solve each inequality. The one on the left has fractions. The least common denominator is a 5. So I'm going to multiply both sides by 5, or 5/1. So 5/1 times 3/5 x, the 5s would reduce down and we'd have 3x. 5 times 1/5, the 5s would reduce down to 1 and we'd have +1. On the right side, we'd have 25. So distributing, multiplying, reducing, we get this. Subtract 1, 3x less than 24, divide by 3x less than 8. All right, so we've solved the first inequality. On the right side, I'll subtract 1, 2x greater than 8, divide by 2x greater than 4, and I'll bring this and down. So again, there's what I'm considering. There's what I'm considering. Ah, yes. Let's take a look at the graphs of each of those. X less than 8. Hang on a second here. Did I copy something wrong? Because this is not turning out the way I wanted it to. So give me just a minute here. Oh well, that's all right. Actually, well, yeah, we'll continue with this one. I did that yesterday too. I copied part of the wrong problem. It's okay, we'll do this problem. X greater than 4 looks like that. So what's the intersection? That. What's the graph of the intersection?
Yeah.
That. And if we just used it in terms of X, it would look like that. So there's your solution in interval notation, and there's the graph. Okay?
Okay.
All right, let's see if I can do what I was trying to do here. Okay, X plus 2. I thought I was being so careful. So X and negative 6x less than negative 9x. Okay. So the first one, we could clear the fractions by multiplying everybody by 3. So we get 3x plus 6 less than negative x. Okay. Add x to both sides. 4x plus 6 less than 0. Subtract 6. 4x less than negative 6. Divide by 4x less than negative 3 halves. On the right, subtract 9x from both sides. Negative 15x less than 0. Divide both sides by negative 15. So I change the direction of the sign because I divided both sides by a negative number. Okay, and then we'll bring this down. So we've got that. All right, let's look at the graphs. Less than negative 3 halves. It's going to look like that. X greater than 0 is going to look like that. What's the intersection? No solution. That's what.
Yeah, there isn't any, hasn't it?
Yeah, that's what I was trying to do on the last one, but I copied one number incorrectly, so it turned out differently. But anyway, okay, no solution. All right, now let's take a look at what's called a double inequality. So, and I believe we had these back in 2.7. So solving this, you want to do, there's 3 pieces. You want to solve it with a variable in the middle, and whatever you do to the middle, you have to do to both ends as well. So if I subtract 3 in the middle to get x by itself, I subtract 3 from both ends as well. Okay. So now, what would that look like in interval notation? And what would that look like graphically? Like that. Okay. So we've looked at and intersections. Let's look at union. Let's say we've got this. Okay, so or. Solving the first inequality, x is less than -1. Solving the second inequality, -x less than -2, dividing by -1, x greater than 2, right? We divided by a negative number, so we'll change the direction and we'll bring this all down here. Okay, so we've solved each inequality. Let's go ahead and graph each individual piece. X is less than -1. This is greater than 2. Oh, you know what? I want to talk about a vacation. Going to Hawaii. I don't know. I just feel like I'm trapped down in my basement, this dungeon, and I just want to think about some happy thoughts. So let's talk about Hawaii for a minute. Now, Hawaii as a state is one unified state, right? But geographically, Hawaii is made up of several islands. There's like Maui and Oahu and the Big Island and Kauai and a couple others, I think. But anyway, so the Union would include all of those islands, right? But geographically, they're separated. You can't just walk from Oahu to the Big Island without getting wet and maybe eaten by a shark, who knows? So even though they're unified, geographically, they're separate. What does that have to do with anything? Well, let's take a look at what we've got here. We've got x less than -1 and x greater than 2. But we want the union. Well, but they don't touch. They're separate entities. So if we graphed the union, it would look like this. We'd have this piece, and we'd have that piece. So there's the graph. Well, what is that going to look like in interval notation? Well, we're going to go from -infinity up to, but not including -1, in union with greater than 2 up to +infinity. So I have to list the union of the two separate pieces because there's a gap between them. Just like Hawaiian Islands, there's a gap between them. Does that make sense?
Yes.
Or are you too busy thinking about laying out on the beach on Hawaii to where this, once I mentioned Hawaii, it was like you were gone, right? Yeah.
Nope. I was
Okay.
just writing down what you were saying. So
Okay. But do you understand the correlation there?
yes.
Okay, now let's take a look at, let's see, this one. 0 less than x, or 3x minus 5 greater than 4x minus 7. So the first thing I want to do is to solve each separate inequality and write it with x on the left. 0 is less than x is the same thing as saying x is greater than 0, okay? The one on the right, I'm going to solve it for x on the left. I'm going to subtract 4x from both sides. So -x minus 5 greater than -7. I'll add 5 to both sides. -x greater than -2. I'll divide by -1, x less than 2. Okay. Remember, I divide, so I by negative, so I change the sign. Let's bring this down here. So there's our situation. Well, let's see, x greater than 0. What does that look like graphically? Everything greater than 0. X less than 2. What does that look like graphically? Everything less than 2. Now, the union, not the intersection. The union, if we take all of this along with all of that, between the two, they've got everything. So it's all real numbers. You okay with that?
I'm slightly confused. So I thought at parentheses it stopped, and because so it would be stop at 0 and 2. So that's why I'm just a little confused.
That's quite all right. That's what usually happens at this point. Consider this. The union, it's everything here as well as everything there, right? Now, you're saying this top one starts right after 0, correct?
Yes.
But isn't 0 included in the bottom one?
Yes.
So it's in the union.
Ah,
How about 2? 2 is not included here, but is 2 included there?
yes.
It's in the union. If either one of them have it, it's in the union.
Okay.
Another
That
example.
makes sense.
Okay, another example. My wife and I, when we got married, we formed a union.
Mhm.
Her name is Sue. I like to say, mi casa es su casa es Sue's casa. All of my stuff, along with all of her stuff, is now our stuff. Okay. Everything either one of us brought, we now have. Now, the intersection would be this piece in the middle, but we're not asking for the intersection. And that's one of the things you got to be careful of, is to keep straight that it's the intersection or it's the union, which is
Okay. That's where my brain was like, oh, wait.
I know, and that's the hard part. Okay, now I want to do one more thing here. Let me see. Where was that problem? 8.4, number 22. Okay. So, give me a minute. Four. Two. Come on. Oops. Almost there. Ah, here we go. Okay. All right, so let's change the view screen to where we can see web assign. Okay. So solve the inequality in part A, then use your work from part A to determine the solution set for the compound inequality in part B. No new work is necessary. All right, let's take a look. Look at part A and look down here at part B. What's the difference between the two? Part A is a union, part B is an intersection. But the two inequalities are the same. So let's take a look, first of all, at part A. Okay. So we've got x plus 2 less than or equal to 10, or, and this is, by the way, this is from 8.4, number 22, x minus 2 greater than or equal to 3. All right. So I'm going to subtract 2. I'm going to get x less than or equal to 8. I'm going to add 2. I'm going to get x greater than or equal to 5. And it's an OR situation. So let's see what that looks like. X less than or equal to 8. We'd have a 0 and an 8 and bracket, an arrow going that way. Okay. X greater than or equal to 5. We'll have a bracket at 5 and an arrow going that way. Okay. We want the union because it says or. So the union would be what? This is like the one we just did. It'd be all real numbers, wouldn't it? So let's see. The graph would look like this, where you'd have arrows going both directions, and interval notation would look like that. Okay. Are you all right with part A?
Yes. Sorry, I couldn't find my cursor.
Yeah. Now, did I do that wrong? No. Okay. So the graph right here would be a solid line like it is down here. This is the correct solution. This is where the student would put it with arrows at both ends. And interval notation, negative infinity to positive infinity, right? Okay, then it says, determine the solution set for the compound inequality in part B, no new work necessary. All right, part B. Well, part A was union. Part B is intersection. Where do these intersect? Between and including 5 and 8. And what would the graph look like? Look like that. No new work necessary, because all we need to do is look at the individual pieces and go, oh, before it was the union, so it was all of this along with all of that. Now it's the intersection, just what they have in common. Okay. You all right with that example?
Yes.
Now, I want to go back to my wife and me. When we got married, okay, we formed a union, all of my stuff along with all of her stuff. We both had record collections. Those are those plastic things with holes in them, not CDs, you know, vinyl, they call them now.
Yes, I know what those are.
I knew you would. Anyway, there was my record collection and her record collection, and we started comparing them. So the union was all of our records. But the intersection was this. It turned out that we both had the same record called The Best of the Guess Who. Guess who? Guess who? The Best of the Guess Who. So that was for the yard sale. So the intersection would have been The Best of the Guess Who. That was what we had in common. The union was everything. The intersection was, we had two of those so we could get rid of one. Does that make any sense? But again,
Yes, it does make sense.
Yeah, keep reminding yourself throughout the problem. Are we doing a union here or are we doing an intersection? Because that's the big thing. People, they forget which one they're doing halfway through the problem. All right, so tonight you've got section 8.4 as well as the chapter 2 review. Tomorrow we'll review. The test is on Friday. Typically what a lot of students do is they wait till tomorrow night to do the chapter review, and that's okay. It's not absolutely due by till Friday, but then if you don't do the review, you don't know what questions you have for tomorrow, okay? Again, on Friday, there'll be no official class meeting. If you come to the Zoom meeting, it'll just say, sorry, no class, just take your test. See you Monday, okay? All right, let me go ahead and stop the recording.